Hey, what's up? It's your old pal, Mr. Cook, and we are working on the fall semester open-ended final exam review. This is the second page. So on the second page, we're still doing some stuff from Unit 1, the inverses of the functions. We start out with Unit 2 on number 13. So, if you need to look at any of the videos involving any of that stuff, just, search the videos on the channel and you'll find a couple of those, especially the group works might be helpful to go over just in case you're not familiar with some of the concepts. They're all in there. Anyways, to find the inverse function of some function, all you have to do is change the variable. So the g of x or the f of x is changed to an x. Then set the other equation, wherever you see an x, put a y instead. So 2y plus 3 over 6. 8y to the third minus 1, and then just solve for y. So we get y by itself. So the first thing we do here is multiply both sides by 6. So we get 6x is equal to 2y plus 3. And then get y by itself, so subtract 3. 6x minus 3 equals 2y. And then divide by 2, so you get y is equal to 6x minus 3 over 2. And there's your inverse function. Same thing here, just get y by itself, so add 1 to both sides. X plus 1 equals 8y to the third. Divide by 8, so x plus 1 over 8 equals y to the third. And then take the cube root of both sides, so you get the cube root of x plus 1 over 8 equals y. And you can stop there. You can simplify it a little bit further, but that's the general idea of how to find the inverse. Okay, now onto the Unit 2 stuff. So we got to find the x-intercepts. Now, whenever you have a rational function or a polynomial function or anything like that, just make sure you factor it first. So let's run factor the top. So let's use the little x method here. So numbers that multiply together to be 30, add together to be negative 13. So those two numbers are going to be, let's see here, negative 3 and negative 10. So we have lead coefficient of 6, so that's 6x minus 3 and 6x minus 10. And then divide out the common factors, so that's 3 here and 2 here, and we get 2x minus 1 and 3x minus 5. All right, so that's what the top part will factor to be. So we've got 2x minus 1, 3x minus 5, and then that's a difference of squares, so that factors to be x minus 3x plus 3. Now, for x-intercepts, all I have to do is just set the top part equal to 0, because if the bottom part equals 0, that's actually a domain restriction. So just take the top part, set them equal to 0, and solve for x. So we've got 2x minus 1 equals 0. So if we solve it, we get x is equal to 1/2. And then 3x minus 5 equals 0. And if we solve that, we get x is equal to 5/3. So that gives us two x-intercepts. One is at 1/2, 0. The other one's going to be at 5/3, 0. Okay, next, use synthetic division to divide right answers as a polynomial with a fractional remainder. Okay, so synthetic division is pretty easy. The part that you're dividing, the divisor, just set that equal to 0 and solve, so you get x equals 1. That's the number that goes in the corner. And then put all your lead coefficients for the rest of it. Remember, if you are missing a term, like we're missing the x here, just remember to put a 0 for the placeholder. So we got 5x to the fourth, 1x to the third, negative 3x squared, 0x, and then 5 for our constant. Underneath the constant, you put the little remainder box. So synthetic division goes like this. You drop down the first number, and then you multiply 5 times 1, so that's 5. Add these numbers together, 1 and 5 is 6. 6 times 1 is 6. 6 minus 3 is 3. 3 times 1 is 3. 0 plus 3 is 3. 3 times 1 is 3. Add these together, you get 8. So now you write it up as a polynomial. So 8 is your remainder, so that's 8 over x minus 1. And then you write in the rest of it. So this is going to be the constant, x squared, x to the third. So 5x to the third plus 6x squared plus 3x, and then plus 3. And there's our polynomial and remainder. And if you need, to remember how to do synthetic division, I, made a bunch of videos on all that stuff. I believe it was in the polynomials one, so that'd be Unit 2, Part B. All right, so 15 and 16 are rational functions. So to find the horizontal or the slant asymptotes, we need to remember what that looks like. So if you're looking for horizontal asymptotes or slant asymptotes, you just compare the degree of the numerator and denominator if the degree is the same. So let's say that you have the degree of the numerator and the degree of the denominator. If the numerator and denominator are equal, then you do have a horizontal asymptote, and it's comparing the coefficient values in the top and then the bottom. If the numerator is smaller than the denominator degree, then that means that your horizontal asymptote is y equals 0. If the numerator is exactly one more than, it's one more than the denominator, and that means you have a slant asymptote and you have to do synthetic division. But then if the numerator is bigger than 1 over the denominator, then you don't have any horizontal asymptotes or slant asymptotes. So in this case, the degree in the top is 2, the degree in the bottom is 2. So we just compare the lead coefficients. Okay, so that means that our horizontal asymptote is y equals 2x squared, so 2 over 3x squared, 3, so y equals 2/3. There you go. Pretty easy once you remember how to find that stuff. The degree in the top is 1 more than the degree in the bottom here, so we have a slant asymptote, and we find that through synthetic division. So just like what we did in number 14, we take the denominator, the divisor, x plus 2, set it equal to 0, so x equals -2. And then, -2 goes in the corner, and then we've got 2x squared, -3x, and then 3 for the constant. So under the constant, we put our remainder. And we actually don't need to find the remainder. We only need to find these two values, because if it's a slant asymptote, it's going to follow the form y equals mx plus b, because it's a slant asymptote. It's a linear equation. So let's just go ahead and run through the synthetic division algorithm. We drop down the 2 there. 2 times -2 is -4. -3 and -4 makes -7. So that gives us the equation 2x minus 7. And if we just put a y in front of it, that's our slant asymptote. We don't care about the remainder at all. All right, next, find the vertical asymptotes of the following. This is actually just an offshoot of these domain and range problems that we have over here, because the domain restrictions that we have, like specific domain restriction values, that gives us vertical asymptotes. So in these cases, here's how we're going to be able to find the vertical asymptotes. We just take the denominator, whatever it is, and then say that it can't be equal to 0. So x squared minus 9 cannot be equal to 0, and then solve. So if I add 9 to both sides, x squared cannot be equal to 9, and then take the square root. X cannot be equal to 3 or -3. So that gives me 2 vertical asymptotes. These are the equations for them. It'd be the line x equals 3, which is a vertical line that passes right through 3, and then also -3. So x equals -3 would be my other vertical asymptote. They're the 2 equations that represent these 2 domain restrictions. And that's what you need to do for part B. Also, just take the bottom part, set it equal to, set it so that it can't be equal to 0 to find your domain restriction. So 3x minus 5 can't be equal to 0, so add 5 to both sides. 3x can't be equal to 5, and therefore x cannot be equal to 5 over 3. And as a vertical asymptote, that's just the equation x equals 5/3. And there's your vertical asymptote. So that's number 17. Number 18, simplify the following and express your answers in standard form. This is definitely one you can do on your calculator with no problems whatsoever. So, just type it in, 4 plus 3i. And you have the I button right down here. So second period, there we go. And then plus parentheses 8 minus 12i. Enter, and you get your answer 12 minus 9i. There we go. Now let's do this one. So we've got the same thing, 4 plus 3i. Now it's minus the other one, so minus 8 minus 12i. You get your answer, -4 plus 15i. -4 plus 15i. There we go. There's the answer for that one. Oh man, multiplication and division with imaginary numbers. Oh yeah, we can do that on our calculator too, I forgot. So let's do it on our calculator. Parentheses 2 plus 3i, and then times 4 minus 2i. Enter, and you get your answer, 14 plus 8i. Easy. And division, you can do that too. Just remember to put parentheses around the top and the bottom. So 2 plus 3i divided by 4 minus 2i. Oops, 2i. There we go. And you get, oh, okay, let's turn that into a fraction. So math, fraction, and it looks like it's 1 plus, and then let's see, let's get those denominators. So that's going to be an 8i over 10. There we go. And, you know, this is going to be multiple choice. I mean, like, that answer will probably be up there. So, you know, don't worry too much about it. Find the zeros of the function. Okay, so, I mean, this should automatically start off the same way that you probably did this on the test. Graph out the equation. So let's see here. 2x to the third power minus 3x squared minus 30x plus 56. Graph. Let's find a couple of those zeros. Oh, there's one at -4, another one at 2, and it looks like somewhere halfway in between 3 and 4. So, I mean, you know, we can use synthetic division to get, you know, that last one there. So we know that -4 is going to work, and also 2. So let's write that down. X equals -4, that's a 0, and also 2. So let's find the third one. And remember, we know that there's 3 zeros because we have, you know, a power of 3, a degree of 3. Okay, so let's use synthetic division. Let's use -4 first. So -4 goes in the corner, and we do 2, -3, -30, and 56, and then double check to make sure you didn't leave any coefficients off. Excuse me. So there's our remainder. It should be 0 at the very end. Let's verify that. So 2 times -4, that's -8. -3 and -8 makes -11. -11 times -4 is a positive 44. 44 minus 30 is 14. 14 times 4, as you imagine, is 56, so -56 there, and we get 0. All right, do synthetic division again. Now we're going to use 2. All right, so 2 drops down, should get 0 for our remainder. 2 times 2 is 4. 4 minus 11 is -7. -7 times 2 is -14. We get a remainder of 0 again. And this gives us the equation 2x minus 7. So all we have to do to find that last 0 is just set it equal to 0 and solve. So add 7 to both sides. 2x equals 7. So that means that our last x value is going to be 7/2. And that's consistent with the graph because 7/2 is 3.5, and it looks like it's right around 3.5. Okay, so those are all 3 of our zeros. Oops, 7 over 2. And of course, I don't know, I'm going to erase around this pencil for whatever reason. There we go. Okay, those are our 3 zeros. Now let's find all those zeros on this one. Notice that it changed from real zeros to just zeros. So I'm willing to bet that this one probably has imaginary zeros just based off of the way that it's worded. Let's verify that. So let's graph it out and find any zeros that are available. So x to the 4th minus 2x to the 3rd plus 6x squared minus 18x minus 27. Excuse me. So we graph it out and see if we have any zeros in sight. Yep, there's one at -1, another one at 3, and don't know of any other ones. So let's just try those out first. -1 and 3, so -1 and 3 for our zeros. Okay, here we go. So use synthetic division. Let's use it with -1 first. So we have 1x to the 4th, -2x to the 3rd, 6x squared, -18x, -27. And then let's use our little synthetic division here. So 1 times -1 is -1. -1 and -2 makes -3. -3 times -1 is +3. 6 and 3 makes 9. 9 times -1 is -9. -9 and -18 makes -27. -27 times -1 is a +27. So we end up with 0. So that's, you know, what we were expecting. Now let's use the other number that we have, 3. So let's use 3 with our synthetic division. 1 times 3 is 3. 3 minus 3 is 0. 0 times 3 is 0. 9 plus 0 is 9. 9 times 3 is 27, and we get another remainder of 0. And we have this remaining polynomial that's going to be 9 for the constant and then 1 for the x squared. So x squared plus 9 equals 0. And we've actually solved that one a couple times by now. Oh, wait, actually we haven't, because this is going to be an imaginary. But it's like a similar one. So we subtract 9 from both sides. X squared is equal to -9. and then take the square root of both sides, and we get x is equal to plus or minus. And then it's the square root of negative 9, so that's going to be a 3. And then when you take the square root of a negative, that's an I. So those are our other two zeros, plus or minus 3i. So that's 1, 2, 3, 4 zeros. And we should have 4 zeros because the degree is 4. There we go. So that's the end of the second page. If you have questions on any of this, don't be afraid to reach out to your teacher, especially in this critical time when we're getting ready for the final exams. So yeah, that should be it. So on to the next page and on to the next video.